All right. I think this is going to be a short one. We're just going over some leftover material from production that's going to be useful in our next lecture. And that's this distinction between the short run and the long run. So there's no precise definition, at least in calendar terms, of how long the short run is, how long the long run is. Sometimes we might even add a third thing in the middle. There's short run, medium run, and long run. These are not precise terms, and they refer to how flexible is a firm in making adjustments to its demands or making adjustments to its output level. And so we can think at the shortest period, the shortest level, time horizon, a firm is stuck with its inventory. It can't even change its level of production, right? So think about what happens if there's suddenly a massive drop in demand, right? So say there's a pandemic and you were, I don't know, massage therapist, right? And all of a sudden, no one wants to be near other humans. Your desire for massage therapy might, the demand, the market demand for massage therapy might plummet. A rational firm, in response to this decreased demand, would want to decrease its level of production, right? However, it cannot do that. It can't do that because maybe it has long-term contracts with its massage therapists, rental agreements with the place that it is doing this massage therapy, blah, blah, blah. There are barriers to being able to quickly adjust. So in the ultra short term, the level of output is fixed. And the only thing that can really change is the price. Now, in our equilibrium model, we're sort of saying that, of course, the firms take their choices as if they're profit maximizing, and so they were price takers. And now I'm saying that they could change the price. Well, this is true, right? They're price takers in the sense that they don't believe their actions are going to change the prices. They're not monopolists who get to determine the price through their action. So they're price takers in the terms of they believed that the price was going to be one thing. They set up their maximization problem or minimization problem, constructed a certain level of capital and labor demand, and then noticed that they had a surplus, right, because of this unforeseen pandemic, and therefore have to cut their price, right? Firms doing this over time will lower the price, and this is one of the things that we said last week helps in price determination and equilibrium, right? So when we have a supply and demand, how does the price actually move towards the equilibrium point? Right? We know that if the price was at the equilibrium point, no one would have an incentive to change their behavior, right? Everything that's being demanded is being supplied, blah, blah, blah. But how does the price actually get there? Well, it could get there through these short-term changes in price. However, in the longer horizon, if I see a dramatic decline in demand, I might want to change my inputs, right? I might want to change my capital and labor demands. And even this can take different amounts of time depending on if it's capital or labor or what kind of the structure is of the particular markets, what kind of capital, what kind of labor. It takes a lot of time to build a factory. If I want to spin up a new factory to build more cars, that might take me years, right? I have to get permits. I have to go potentially lobby to get the regulation in place to build certain kinds of things. I have to get architects and technicians and blah, blah, blah. This could be quite a difficult process. Hiring new labor is probably slightly easier. It still takes some time. It takes a couple of months maybe or a couple of weeks to set an ad, do interviews, run paperwork with the government to pay taxes and things, but labor seems to be more responsive than capital is the point. It could be the other way around too. In certain circumstances, we sign very long-term labor contracts, such as in a university. There's a notion of tenure. You have infinitely lived labor contracts, and so it could be that your labor is actually harder to adjust. But the point is that in the very long run, both labor and capital are flexible, and that's sort of the model that we were using when we were talking about production. We assumed that the firm could choose both its level of capital and its level of labor. For this little lecture, we're going to look at what happens if the firm can only choose its labor and its level of capital is fixed. We're not going to do too much with it. It's just a little snappy snap. Okay, so in the ultra long run, even fixed costs are in some sense mutable because firms can enter and leave the market, right? So a firm that's making a positive profit, if firms are making a negative profit, they're not covering their fixed costs, they can shut down. In which case they're going to make a profit of zero in the ultra long run, and they don't have to worry about fixed costs because they shut down. They could sell off their factory or whatever. If I observe that in some place there's economic profits to be made, that is that there's positive profits to be made more than across any other industry, then I could move to that, right? I could invest in it. I could build an airline. I could build a factory to build airplanes or whatever. And if I had enough time and I could convince investors to do that, I could get that done. So in the long run, firms can enter and leave the market. So here we're going to take a very simple definition that in the long run, that should say short run, in the short run, the level of capital is fixed at some determined K bar. This is the level of capital that the firm has entering the period, and it can't do anything about it. It can, if it wants to build a new factory, it has to think of years in advance, right? And right now, its level is fixed at K bar. This constraint increases the cost of production at every level. And what do I mean by the cost of production? So remember that the cost function of the firm is the cost minimization, the solution to the cost minimization being plugged back into the cost function as a function of how much the firm wants to produce. So it says, what is the minimum cost to produce Q bar units of output, where Q bar is a variable ranging from 0 on upwards. And at each level of production, we can determine what's the most efficient way to produce that level of production. And we used to allow the firm to choose both capital and labor. And now we're saying it has to choose K bar for its capital. It can choose whatever labor level it wants. And this is going to increase the cost of production. The cost function will be point-wise higher for every level of production. And the reason is that we're just adding a constraint to the firm. So they're taking the same minimization problem with an additional constraint. That means that they can't optimize as efficiently because they can make less choices that they could before. Anything they could do before, anything they could do when they could change capital, they can still do without changing capital. Anything they can do when they can't change capital, they can still do when they change capital. They could choose K bar, but they don't have the additional flexibility of making an additional choice about the capital, and so this can only hurt them. Right? It's an extra constraint can only ever hurt a maximization or minimization problem. So we're minimizing something, we add an extra constraint, it can't possibly make the solution any smaller. So if we look here, this is like the expansion path of a firm. Now, K1 is the fixed level of capital that the firm has to produce at, right? So this K1, the horizontal line, is the fixed level of capital. So it has to choose a point on that horizontal line. Now, the different isoquants, if it produces Q0, there's only one level of labor that, along with K1, satisfies the production is on the isoquant Q0, right? So its hands are tied in terms of how much labor to produce. It has to produce L0 labor, right? And the same thing with Q1 and Q2. You have to choose L1 and L2. I guess you could hire more labor and overproduce above Q0, but of course that's inefficient, right? It's feasible, but it's inefficient. So the obvious cost minimizing thing is to produce at the level where you're exactly producing the required Q0, Q1, Q2 level of production, and to do that is just where this isoquant intersects with the fixed level of capital. Now notice that the cost of production there the cost of production is L0 times the price of capital, labor, and K0 times the price, K1 times the price of capital for each of those three dots. Each of the 3 points, L0, K1, L1, K1, L2, K1. And we can look at the isocost lines, right? So the isocost lines are the diagonal lines that intersect those points, and those represent lines of constant cost for the firm. We can see that L0 is an overconsumption of capital. They're demanding more capital than they should. They could produce at the same level Q0, but at a lower cost by lowering capital, right? So if we look along the isoquant is steeper than the isocost line. And so as we move down along the isoquant, we're keeping production level fixed, but we are decreasing our costs, right? Because we're moving closer to the origin. So if they were able to adjust, they could lower their demand for capital, increase their demand for labor, and this would save them money, keeping their production at the level Q0. At the level Q1, K1 is actually the efficient thing to do. That means that the short-run cost is going to be the same as the long-run cost because they don't want to actually change their level of capital. They're right on it. At Q2, we have the opposite of what was happening at Q0, and now there's an under consumption of capital, an under demand for capital. Capital is fixed at K1, but as we move up along the isoquant, we see that we would be trading off extra capital for less labor. We'd be selling labor or hiring less labor, hiring more capital. That would save us costs, but keep us on the line Q2, because here the isoquant is shallower than the corresponding isocost line. So you can see that, at low levels of production, this is going to be bad because you're going to be overproducing, you're going to be overhiring capital. At high levels of production, this is going to be bad because you're going to be underhiring capital. And in the middle, somewhere, there's a sweet spot where this actually happened to be the correct amount of capital for the job. Maybe, and it doesn't have to be like that. I mean, that's the general logic, but that's... So you can see that if you look at Q, this is for different levels of fixed capital, K0, K1, K2. You can see that that's always these are your cost functions. The cost function, the short run cost function associated with K0 is pointwise above the cost function in the long run, which is given by the lower envelope, which is C. It intersects C exactly at that point that was in the previous graph where you have the efficient level. So if you're supposed to be producing Q0 units of the output and you use K0 units of capital, that's actually the efficient amount of capital. So at that point, the short run costs and the long run costs coincide because there's no actual constraint on you, or the constraint is met automatically. As you increase production, that efficient level of capital is increasing. And so you can see that K1, which is some higher level of fixed capital, has a point where it intersects the cost curve at a higher point. K2 at some higher point yet. And the cost curve is going to be the lower envelope. It's where all of these individual short-run costs, the lower point of all of them. So you take the lower envelope of a family of functions is the point-wise minimum of all of those functions. And that is all we have to say about that. And this will come in handy when we start thinking about long-run versus short-run supply curves in an equilibrium, which is where we're headed and why we introduce this stuff.